Hello everyone, I am Govindaraman, currently pursuing my engineering degree in Sri Venkateswara College of Engineering with AI as my specialization. So in this presentation, we will be studying about the introduction of pumping lemma theorem and its applications. So what is pumping lemma theorem? It is a fundamental theorem in the field of formal language theory where it provides a method for proving that certain languages are not regular. In this theorem is essential for understanding the limitations of regular languages and plays a significant role in study of computational linguistics and automata theory. Moving on, let us understand the formal definition of the pumping lemma. Key elements. The formal definition of pumping lemma involves specific conditions and constraints that must be satisfied for a language to be considered regular. These elements provide a structured framework for evaluating the regularity of languages. The formalization of pumping lemma often includes mathematical symbols and expressions which are used to represent the properties and characteristics of regular and non-regular languages. Proofs techniques. Understanding the formal definition includes grasping the various proof techniques such as contradiction, contrapositive, which are commonly employed in demonstrating the validation for pumping lemma. Applying the pumping lemma to prove that the language is not regular. Selection of language. Choose a specific language for analysis and apply conditions of the pumping lemma to assess its regularity. The second step would be verification of condition. Verify whether the chosen language fulfills the requirements outlined in the theorem. Third one is logical deduction. Use logical deduction to present a compelling argument for the non-regularity of the language based on findings. Let us see the examples of using pumping lemma to prove non-regularity. Language. Analyze an example language and demonstrate how the pumping lemma is used to establish its non-regular characteristics. Language 2. Explore another instance where the application of pumping lemma effectively identifies a regular as a non-regular. Third, provide an additional case study showcasing the practical implementation of the pumping lemma for non-regularity proof. Moving on, let us see the limitations and assumptions of the pumping lemma. The first one would be finite automata, second one is context-free languages, third is edge cases. Finite automata. Discuss the assumptions made by the pumping lemma regarding the behavior and structure of a finite automata. Context-free languages. Examine the limitations of applying the pumping lemma to languages beyond the scope of regular languages such as context-free languages. Edge cases. Highlight the scenarios where the pumping lemma might provide inconclusive or encounter challenges in accurately characterizing language regularity. Moving on. The extensions and variations of pumping lemma. Extended theorem explores the evaluation of original pumping lemma into extended and modified version to accommodate different types of languages. Multiple constraints examines variations of pumping lemma that introduce additional constraints and conditions for regularity assessment. Moving on. Let us see what are the applications of pumping lemma in language theory. The first one would be formal language hierarchy. The second is language recognition. If we look into the first one, that is formal language hierarchy, understanding how the pumping lemma contributes to the classification of languages within the formal language hierarchy. The second one is language recognition, highlighting the role of pumping lemma in aiding the recognition and differentiation of various language types. Moving on, using the pumping lemma to prove closure properties of regular languages. The first one is intersection, second will be union, third will be concatenation. Intersection, illustrating how pumping lemma can be applied to demonstrate the closure of regular languages under intersection. Exploring the usage of pumping lemma to establish the closure of regular languages is under union operations. Third one, providing examples of utilizing the pumping lemma to prove the closure of regular languages under concatenation. Critics and criticism of the pumping lemma. Explore the various criticisms and challenges posed by researchers and scholars regarding the reliability and applicability of the pumping lemma in assessing language regularity. Conclusion and summary of the pumping lemma and its significance. The first is, let us see the theorem recap. Summarize the foundational elements and principles of pumping lemma, reinforcing its significance in formal language theory. Real-world applications. Highlight the practical implications and real-world significance of the pumping lemma in computational linguistics and related fields. Third one, future prospects. Discuss potential avenues for the further research and enhancement of pumping lemma to address its limitations and expand its utility. Thank you.